So we've just seen how we can, if we multiply a number by its conjugate, we get left with a real number only. Okay, which doesn't seem to have any practicality really, but here's a use for it. What we're going to do here is we're going to divide this complex number by this complex number, and then we're going to see what the result is. We saw how easy it was to multiply them together. A little bit more work's needed when they're dividing, and that's where the conjugate comes in. In theory, we can't divide anything by a complex number. Straightforward. So what we're going to do is we're going to make use of the conjugate to achieve this aim. So the thing to do first is make this equal to itself. Now, no one can disagree that that is identical to that, it's equal to that, because they're the same. So what we're going to do now is we're going to use the conjugate process to make this whole bottom term real. So we'll multiply it by its conjugate, 3 minus j4. Conjugate being where the only difference between the two is the sign in front of the j term, the imaginary term. Obviously, to keep a formula equation balanced, you can't just do that as you wish, unless you do this opposite term, which is do the same to the top. Okay, so your rules of maths say you can't just, you've got to keep everything balanced. So it's like a set of scales, you can't just stick 3 apples on one side and then expect it to stay balanced unless you take 3 apples away. Or you can't times it by 3 unless you divide it by 3. So you're keeping it balanced. So in effect, another way of looking at it is this divided by this is 1, times anything by the 1, it stays the same. Okay, so that's the first step. Okay, let's multiply this out. So we've got 2 times 3 is 6, 2 times minus j4 is minus j8, then we've got minus j3 times 3 is minus j9, and then we've got a minus times a minus, so it's going to be plus, and then we've got j times j, so it's going to be j squared, and then finally 3 times 4 is 12. Now on the bottom we can obviously do the same process, but we know, because we know the shortcut, if we square that and add them together, we gets us to the same place. So 3 squared is 9, 4 squared is 16, so that's 20 what we're saying, 3 squared is 9, and 4 squared is 16, so it's 25. Maths got too hard for me then. Okay, 25. So moving on, I've now got, so we know that this becomes a minus sign, this j squared makes this into a minus sign, so we've got minus 12, so we've got 6 minus 12, so we're going to have minus 6, and then we've got plus minus j8 minus j9 is going to give you minus j17, and that's all over 25. Strictly speaking though, this is not a complex number because we need to divide this 25 up. It's a common denominator, you could say, like you did right back at primary school when you made numbers into, to do fractions, you had to come up with a common term on the bottom, so a common denominator. So we've got a common denominator here, so we have to split it. So minus 6 over 25 minus j17 over 25. And that's your final, that's the final answer, that's a complex number. Obviously, you can divide them and make them into decimal numbers. Personally, I prefer them like that as fractions because they're precise values. If I start dividing these through, I'm going to get decimal points, I'm going to get rounding errors. So the most precise answer is to leave it like that. Okay, thank you.